In this class, we'll learn about the concept of Ohm's law from the chapter Electricity, class 10. So first we see what does this Ohm's law will gives us. So here, the Ohm's law explains the relationship between potential difference and electric current. Okay, this law is going to explain how the potential difference and electric current are related. Okay, and we got a condition here, that is temperature should remain constant. Then the law will be valid. If the temperature is not remain constant, the relation what the Ohm's law will give between the potential difference and electric current is not valid. Okay. So let's see what is the relation that the Ohm's law has given. Okay. So here you see that at constant temperature, the temperature should remain constant. Okay, the temperature should remain constant. Then the current flowing through the conductor, is directly proportional to the potential difference, across its end. That means if you take a conductor and let's say a potential difference of 1 volt is present in between the ends of this conductor, then let's say 1 ampere of current is passing through the conductor. Now, if you increase the potential difference across this conductor, the current also increases. The electric current flowing through that conductor get also increases. Let's say 2 amperes. If you decrease the potential difference across the conductor, then the amount of current passing through it also decreases. So that from this statement, we can relate the potential difference and electric current likewise. That is, V is directly proportional to I. Here, V is potential difference, I is electric current. Further, we can write this expression like V is equals to R into I. What is this R? The R is a proportionality constant and it is named as resistance. We will learn about the resistance later. So here we got an expression that V is equals to R into I, right? So this is Ohm's law. What is Ohm's law? At constant temperature, the current flowing through the conductor is directly proportional to the potential difference across its end. Okay. Yes. We will see the mathematical expression, that is V is equals to IR, we have seen, right? So it can be further written like I is equals to V by R. Here you can see that if you take this R to the LHS, let's say to the other side, you can write I is equals to V by R. Or else, if you send this I to the other side, you will get R is equals to V by I, right? Here you can see a Ohm's law triangle. Let's say V is equals to, if you want to find the potential difference and you got electric current and resistance of the conductor. Now you can take this as V is equals to I into R. Instead, if you want to measure I, that is I is equals to, this is V by R. You can see here V by R, right? Or else if you want to know what is R value, that is R is equals to, you can see here R is equals to V by I. R is equals to V by I. So this triangle give you the relation between V, I and R, and how we use this mathematical expression in numericals, we will see at the end of this session. Okay. Yes. And next to this, we see the Ohm's law experimentally. Here we will see a few things with few readings. So let's say first we will take a circuit. In the circuit, what you can find? A battery, a key, rheostat, resistor, that is which has a certain resistance, voltmeter, it is connected parallel to the resistor, and ammeter, it is connected in series connection with the resistor, right? This is the circuit that what we have taken for this experiment. Now let's say the potential difference, that is, let's say the potential difference, nothing but a battery which is connected here is a 2.45 volts battery. Okay, in the first case, the potential difference maintained across the resistor in the circuit is 2.5. Now, let's take a reading from the ammeter, that is 0.1. Let's say that we got a potential difference in the voltmeter as 2.5 and ammeter reading is 0.1. Now, if you take a V by I ratio, V by I ratio will give you the resistance of that resistor, right? So, if you solve this, that is, let's say 2.5 by 0.1 is equals to, you will get 25, right? Yes. Now, further you are going to take the next case, that is now you are changing the potential difference. Let's say in the second case, we got 5 volts. Now, the current passing through the conductor is taken as 0.2. Now, if you take a V by I ratio, that is 5 by 0.2, you will get 50 by 20. You can divide and multiply with 10, so that you will get 50 by 2, right? So that you can get 25 here. And in third case, again, you have taken a potential difference of 10 volts and the current passing through the resistor is 0.4. And taking the ratio of this, V by I ratio, you will get 25 ohms again. So further you keep increasing the potential difference, you can see that the current also get increases along with the potential difference across the resistor. But here, if you observe this last column, in all the cases, the V by I ratio remains constant. That you got the R value as 25 ohms, right? The R remains constant. So from this activity, we can prove that the resistance of the resistor is constant, whereas by increasing the potential difference, we can see the increase in the current passing through it, current passing through the resistor, right? Yes. So from this activity, we can conclude that current passing through the resistor is directly proportional to the potential difference across it at constant temperature, right? Yes. And if you mark the graph for this experiment, you can find the graph here. So here you can see that the current is taken on x-axis, okay? And the potential difference is taken on y-axis. Now you will get a straight line from the origin. Why? Because the R value remains constant. Here the slope of this graph will give you the resistance, will give you the value of resistance. So this is the graph for the Ohm's law, okay, where R remains constant and the current increases with the potential difference, right? Yes. And next to this, we will see that one more concept based on this Ohm's law. The conductors are further classified into ohmic and non-ohmic conductors. Based on Ohm's law, conductors are classified as ohmic and non-ohmic conductors. Let's see what are these ohmic and non-ohmic conductors. First, here you can see that conductors which don't obey the Ohm's law, we call these as non-ohmic conductors. We call these conductors as non-ohmic conductors. That means here they won't obey the Ohm's law. What does it mean? That is, electric current is not directly proportional to the potential difference across the conductor. Okay, such conductors are said to be the non-ohmic conductors. Example, LED, transistors, you can take diodes, that is LED, right? And you can also take vacuum tubes, etc. So such a electronic components are all considered as non-ohmic conductors, which don't obey the Ohm's law. And if you take a graph between the potential difference and electric current, here you see that the graph what you get is a curve. It is not a straight line, right? Yes. So this is all about non-ohmic conductors. And whereas on other hand, you can see conductors, a few conductors that they obey the Ohm's law. Conductors which obey Ohm's law are said to be the ohmic conductors. We can call them as ohmic conductors. Almost all metals are ohmic conductors. They will obey the Ohm's law, so that with increase in the potential difference, the electric current also get increase across the conductor, so that you will get a straight line graph. Okay, so this graph indicates that these conductors are ohmic conductors, and this curved graph indicates that the conductors are non-ohmic conductors. Done? Okay. Now we see numericals related to this Ohm's law. Let's see the first question. A simple electric circuit has 12 volts battery. Okay, that is the potential difference is 12 volts, and a resistor of 2 ohms. Resistor of 2 ohms. That is a resistor whose resistance is 2 ohms. Calculate the current flowing through the circuit. We need to calculate current, that is I. Okay, so from Ohm's law, we will get a mathematical expression, that is I is equals to V by R, right? So substituting the values here, let's say I is equals to, what is V? 12. What is R? 2, right? 2 ones are 2 6 are. So that the current passing through that circuit is 6 amperes. Is 6 amperes, right? Yes. And we will see one more numerical related to this concept. Let's see the question 2 now. An electric appliance allows a current of 4 amperes. How much current? 4 amperes. When connected to 220 volts power supply. 220 volts power supply. Here power supply is nothing but a battery, right? So that we can say that potential difference is 220 volts. What is the resistance of the appliance? We need to find the resistance of the appliance. So what formula you can write here? Resistance R is equals to V by I. Okay, so if you plug in these values, we got V 220 and I is 4 amperes, that is 4, right? If you further solve it, you can say 4 5 is 20, right? 2 will get remained here, it will become 20 again. So that 4 5 is 20 again. So finally, what is the resistance that you got? 55 ohms. 55 ohms is the resistance of the appliance given. Okay, and next we see the third numerical. Here in the third question, we got a resistor of 100 ohms. That is, the resistance of the given resistor is 100 ohms, is connected in a circuit. If the current flowing through it, is 0.5 amperes. That is, how much current is passing through that? 0.5 amperes. What is the potential difference across the resistor? So that we need to find potential difference, that is V. So if you take the relation between V, I and R, you can write V is equals to IR. V is equals to IR. That is, V is equals to current. How much? 0.5. And what is R? 100. Right? Yes. You take off 1 0 and the decimal part here, so that 5 into 10, you will get 50. What is this? Potential difference. 50 volts is the potential difference across the resistor. Done? Yes.